Hello class, welcome to lesson 11.7, which is all about mixed expressions and complex fractions. By the end of this lesson, you should be able to simplify both of those, okay? So let's start by looking at our first example where we want to write each mixed expression as a rational expression. So mixed, as you can see, is a whole number and then a fraction, okay? What we want to do is we want to make it one term, okay, one expression. The way that we do this is we have to add 2 plus our 5 over x. The only problem with this plan is the fact that our 2 doesn't have a common denominator with 5 over x, so we can't add them together. However, just like when we used to add normal fractions, like 3/4 plus 2/3, you find a common denominator and you adjust, okay? We're going to do that same thing. The denominator that we need is x, so all I'm going to do is I'm going to take my 2, and that's just like 2 over 1. I'm going to multiply that by x. That means my x gets multiplied to the top and the bottom, and this becomes 2x over x, which if you do what we've been doing in the past couple sections, if you were to simplify this, you would get back to the 2. Okay, so that shows you that you have converted your whole number to a fraction properly. And now we would just want to add 5 over x. So we have our common denominator. We have 2 different terms. They are not like terms, so we can't completely combine them. But we can write it as 2x plus 5 all over x. Alright, so that's what we're looking to do in this section. Now let's try that same process with this 6y over 4y plus 8 plus 5y. Again, we have a denominator of 4y plus 8, and we have a regular, just 5y. So let's multiply our single term by our denominator and get our fraction that we can combine. So we keep our 6y over 4y plus 8, and then we want to add that to, we're going to have a 4y plus 8 as our denominator. And then if we multiply our numerator, our 5y times our 4y plus 8, 5y times 4y, I'm going to have 5 times 4 is 20, and then y times y gives me a y squared. And then I have 5y times 8, so I do my plus, and 5 times 8 gives me, ooh, not 80. Not 80. 40 though. 5 times 8 definitely gives me 40y. Now I can keep going and I can combine some like terms in our numerator now because we have the same denominator. So let's keep our 4y plus 8 as our denominator. And we now have a 20y squared. And then we can combine our 6y and our 40y. So we have a 46y. If I look at all of those numbers, I notice that they are all even. So what I can do is I can still simplify this. If I divide everything by 2, I now have a 10y squared plus 23y all over 2y plus 4. Now I have 3 even numbers and 1 odd, so that means it's no longer divisible by 2. And it looks like that's as simplified down as I can get for an answer. So I'm going to just circle that to show that that is the final product. That is the simplified expression. Why don't you take a minute and see if you can solve this one on your own? Hopefully you ended up with letter B as your final answer. If not, be sure to ask either myself or a friend. Let's take a look at our second example. We have a top fuel dragster can cover 1/4 mile or a quarter mile in 4 2/5 seconds. The average speed in miles per second can be described by a complex fraction. Okay, so that's what we're going to focus on here. A complex fraction is a fraction within a fraction, okay? So think Inception, but fraction style, okay? If the dragster can cover 1/4 mile in 3 1/8 seconds, what is the average speed in miles per minute? Okay, so a couple things I see. The top just tells us what a top fuel dragster can do. And now looking down below, we are given some certain criteria. We know that this dragster can cover a quarter mile in 3 1/8 seconds. And we want to know the average speed in miles per minute. Something that should raise a red flag is the fact that I have seconds up there and then I have minute down below. That means I'm going to have to convert my my seconds to minutes. The way that you can do that, so we're going to set up our complex fraction. If we do the distance divided by the time, right? Because miles per hour, miles on top, hour on the bottom. In this case, miles per seconds or minutes. The time's going to go down below. So we have 1/4 over 3 1/8. And this is seconds. This is miles. And then we want to convert from seconds to minutes. So I can say if I have seconds down below, I want them up top in order to cancel with each other. I'm just going to put an S. So 60 seconds equals 1 minute. And then once I multiply these together, I should get my final answer. But you might be thinking, Ms. Johnson, there's fractions within the fractions. What do I do? If you're one of these people, you're probably not alone. We have 1/4 miles. We have 60 seconds on top. What we're going to do is we're going to multiply the fraction and the whole number together. So we are left with 60 over 4 on our top number. Okay, 60 over 4. And you're probably thinking, they're both even. Let's simplify them. Hold that thought, okay? I promise that you will get to simplify, just not yet. Now on the bottom, we have a 3 1/8 and a 1. Let's multiply those together. Except I don't like having this mixed number here. I want to change this to an improper fraction. So what I do, 8 times 3 is 24 plus 1. I have 25 over, my denominator stays the same, 8. And 25 over 8 times 1 is still 25 over 8. Now we're going to take this complex fraction and rewrite it, okay? We take our top fraction, so that's 60 over 4, and now we are going to multiply by the reciprocal, because remember, with dividing, this is basically a division bar. We're dividing two fractions. Dividing fractions is the same as multiplying by the reciprocal. So now we have the reciprocal of our denominator. Remember, our denominator is 25/8. So instead, 8's going to be on the top, 25 is going to be on the bottom. And now I'm just going to solve. 4 goes into itself once. 4 goes into 8 twice. 5 goes into 25 5 times, and I know 5 goes into 60 12 times. Now if I multiply across, I have 12 times 2, which gives me 24, and then 1 times 5 gives me 5. So 24/5 miles per minute is my label. Except I don't like that fraction because I don't fully understand what that means. So what I'm going to do is I'm going to convert that. 5 goes into 24 times with 4 left over. So it goes 4 4/5 miles per minute. That's a little bit easier for our brains to grasp and understand how far that is. Okay, 4 4/5 miles per minute. I bet you guys would like to have a mile speed that fast. All right, now why don't you take a minute and try to figure out this baking scenario and see how your cookies would turn out. Okay, not really, but how many? All right, hopefully you ended up with 27 cookies. If not, be sure to ask either myself or a friend. We'd be more than happy to help. Let's move on to example 3. We want to simplify each expression. So I'm not sure why one of them is much larger than the other. My apologies. Let's fix that. Okay, so we have g cubed times h over b all over g h cubed over b squared. So again, remember this middle fraction bar here is where it divides. It's a fraction divided by a fraction. So what we're going to do, we're going to say g cubed h over b, and then we have our little divided by. When we divide fractions, it's the same as multiplying by the reciprocal. So now I'm going to flip this fraction This now becomes my top. This is my bottom. Okay, so now I have b squared g h cubed. Now it's just simplifying like we have been. Here's a g. We can cancel a g out. That's now g squared. Here's an h. Can cancel that cubed out. It's now a squared. There's a b here. This is now just a 1. So on the top left, we have a g squared. On the bottom, we have a 1 times, and then we have a b over h squared. And if we combine those, we have a g squared b all over h squared. Alright? Hopefully that's not too difficult for you. If that doesn't make sense, that's okay. We're going to do another example. Hopefully it will help. Otherwise, you can always rewind. That is one of the beauties of having our little flipped classroom, is you can go back and rewatch something that I maybe went a little too fast for you to understand the first time. Alright, again, we have a fraction within a fraction. Let's divide. Let's figure out what's our first fraction. Our first fraction is right here. I'm going to rewrite that down below. So I'm going to take my negative 24 m cubed t to the 5th. You always leave your top fraction the same. You do not do the reciprocal of your top fraction. And then we are going to multiply by the reciprocal of our bottom fraction. So the reciprocal of our bottom fraction, which is t to the 4th h, becomes our top, all over 16p m squared. Okay, I can reduce on my diagonals, so I'm going to do that. I see a negative 24 and a positive 16. I know 8 is a factor of both of those, so it becomes a negative 3 and a positive 2. And then I see an m cubed and an m squared, so this is gone. We're left with just an m in the top left. I see a t to the 5th and then a p, so those don't cancel at all. So we're done with the first diagonal. Now our next diagonal, we have a p squared h and a t to the 4th h. So those h's are going to cancel. Let's rewrite what we have left. We have a negative 3 m t to the 5th all over p squared times t to the 4th all over p. If we multiply across, we now have negative 3 m t to the, is it the 9th or the 20th? When you're multiplying powers together, you just have to add them, remember? So this is going to be t to the 9th. It tells me how many of them we have. And then p to the 2nd times p gives me p cubed, because this is like having a 1 there. So 2 plus 1, that gives me 3. And there is my final answer. Alright, it is your turn to try. See if you can simplify this expression. Hopefully you ended up with q squared r cubed. If not, be sure to ask for help. Be more than happy to help. And let's look at our final example. We want to simplify these expressions. This is more of basically the same thing, but instead of just canceling one thing at a time, we're going to be canceling stuff in parentheses, okay? So let's rewrite our first example. We have a plus 7 over 4 times the reciprocal of our denominator, which is 10 over a squared minus 49. And if I keep going, I keep my a plus 7. 4 and 10, I know I have a 2 that can cancel in each, so 4 divided by 2 is 2. 10 divided by 2 is 5. Alright, and then I can rewrite a squared minus 49, that's the difference of squares. That means I can write it as a plus 7 times a minus 7. And if I keep going, I now have, I can cancel an a plus 7 from the top and the bottom, and I'm left with a 5 on top, because this is a 1 now. And then I have a 2 times a minus 7. And that is as reduced as I can get with that example. Okay? let's try our next one, see how we do there. First, let's start by rewriting it so it's not a complex fraction. So I'm going to rewrite x plus 4 over x minus 1 times, and then 2x minus 2 becomes the numerator. We have x squared plus 6x plus 8 is our denominator. I'm going to bring my x plus 4 down and my x minus 1, because those are both as simplified as they can be. Then I look at my 2x minus 2, that both of those terms have a 2, so I'm going to pull that out, and I'm left with x minus 1 all over. And then let's see, what can we break this up into? I want something that multiplies to an 8 and adds to a 6. So I have my x's, and then multiplies to 8, adds to 6. I think I'm going to use my 4 and my 2. If I keep going from there, I now have an x plus 4 and x plus 4 and x minus 1 and x minus 1. So this is 1 times 2, because I have my 1 times my 2. That's it. And then I have 1 times x plus 2. That's all that's left after all of that. So even though it looks big and scary right away, doesn't mean that you're going to have a big, long, scary answer, okay? Why don't you take a minute and try one on your own? Hopefully you ended up with c plus 1 over c minus 4. If not, that's okay. Try this one. Okay, hopefully with this one you got a plus 3 over quantity of a plus 1 times quantity a plus 4. If that is not the answer you got, or you have questions on any part of the video, be sure to either reach out to myself or a friend. I'd be more than happy to help. I hope you guys have a great night.